Hey everybody, it's me. I'm here. I know you're excited. Today we're going to learn a little bit about the rock cycle. You might be like, rock cycle? I feel like we did this forever ago. Yeah, you probably did. I think you did it in 8th grade. So it might have been a minute since you've talked about the rock cycle. So let's talk about it. Okay, there are 3 types of rocks. Nice and easy to remember. Igneous, sedimentary, and metamorphic rocks. I will be honest, this is not a PowerPoint that I made. So credit to whoever made it, except you used Comic Sans font. So that's like a no-no. That's a boo-boo no-no. Don't use that font. Just kidding. I feel like all teachers at some point used Comic Sans for some reason. Anyway, back to reality. Those are the 3 types of rock: igneous, sedimentary, and metamorphic. Let's look at igneous rock. I know my head is blocking a bunch. But igneous rock is made when magma is basically liquid rock that's found underneath the surface of the earth. Once it pops out onto the surface through something like a volcano, we call it lava. It's literally the same thing. So magma and lava are literally the same thing. Magma is just inside the earth. Lava is once it's on top of the earth. So feel free, if you see a movie, like to correct people and be like, actually, that's lava, not magma. So there. Anyway, so igneous rock can form in 2 different ways. It can form from lava that cools very fast. Think about a volcano. If you've ever seen, like, I'm sure it's been on TikTok. I've old person seen it in places, not on TikTok, but I've seen it in other places. Think about a volcano that's like in Hawaii or something, and it's erupting, and this lava is flowing down. It's not really that fast, but sometimes it can be. It's flowing down the side of this volcano and into the ocean. Well, that's going to cool like that. Okay, the ocean water is going to cool and harden and solidify this lava. And so those types of rock can be very light. They can be glassy, like basalt. And some rocks that, and here's one that has formed quickly, actually. This is not glassy. This is volcanic pyroclast. It was blown out of a volcano. And so when you say light and airy, it's full of holes, because this one didn't slide down a mountain and into the ocean. It flew through the air. So air got into it and made little pockets. But some rocks, some igneous rocks, can form kind of underneath the surface of the earth. So they're formed by magma, and the magma cools, but it cools very, very, very slowly. And a lot of times those rocks can be very hard and have more colors. You might see like granules or grains in them. So these are all pictures of igneous rocks. What about sedimentary rock? I feel like, honestly, you guys are probably most familiar with sedimentary rock. So sedimentary rock is made when sediments like sand or gravel or dirt or even remains of living things are pressed together over time and become rock. This is the type of rock where you see fossils. Where's my fossil? Is it the time? Yes, it's the time for fossils. So this is my fossilized Spinosaurus tooth. Ignore the giant crack in the glue. I let my daughter hold it because she was interested. I mean, this is my own mistake. She was 3 at the time that this happened, and she didn't throw it or whip it at anything. She dropped it onto carpet, and 99 million years old, it was fine. And she dropped it onto the carpet, and it cracked. That was sad. But anyway, you would find that type of fossil in sedimentary rock. But anyway, after a long, 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 long time, when those sediments get pressed together and stuck together, they become rock. Sedimentary rock is formed in layers. So you can see those layers here. We're kind of in a flat area, so you probably haven't seen too much of this in real life. So here are some pictures of sedimentary rock. That's where you find fossils. And then we have metamorphic rock. I like metamorphic rock. I can't decide. It's like my favorite organelle. Certain days I have certain favorite rocks. And today I think is a metamorphic rock day because I think some of them look really, really cool. Metamorphic rocks are made from other rocks. And how do they get made? So heat and pressure. So you have whatever rock, a sedimentary rock with its layers, or an igneous rock with its grains. It gets pushed underneath the earth somehow. And as it's getting pushed underneath the crust, it's getting added a lot of pressure to it. It's being squeezed. Heat comes in, maybe partially melts it. It doesn't melt totally, it partially melts. And so you have this squishing and squeezing and heating, kind of like you took like something you made of Play-Doh and you kind of squished it a little bit. You can kind of see the original thing that was there, but now it's like squished or stretched. So you can think of it like how a caterpillar becomes a butterfly, like metamorphosis. It changes. Maybe that's why it's that word. And so here are some metamorphic rocks. Also have the coolest names. There's one that I won't say in this video. I'll tell you when I'm back in person. But one of them is literally called Gneiss, Gneiss, Gneiss. So I always want to see like that kind of rock and just be like, nice. So these are some pictures of metamorphic rock. A lot of times you can see bands or wavy lines in them because of how they were squeezed and moved. And so here's the rock cycle. Here's a simple diagram of the rock cycle. You can see, and you will see, like a lot of different diagrams. If you notice, okay, well, here we have this outside cycle going around. And then there's all these lines crisscrossing inside, because it's not like a literal cycle like this, where it just kind of goes around. Any rock can change into another rock at any point in time in the rock cycle. And any rock can kind of go back and become the same rock. Like you can have an igneous rock that's formed underground and then melts back into magma and then forms and melts back into magma for millions of years. So let's just start anywhere at the rock cycle. Let's start right here with melting. Well, it's going to crystallize, which means it's going to turn into a solid. Think of like water turning into ice. You see the little ice crystals form, and then you have an ice cube. Well, that's going to make igneous rock. Is ice an igneous rock? You can see here there are arrows. We can follow along on the outside, but you can see, and this is what I want to point out, that igneous rock can go here, it can go here, and then here's the line for it going in this direction. So it can go back to just being igneous rock continuously. It can go and metamorphose and become metamorphic rock, or the way that we're going to go, it could become sediment and become sedimentary rock. So I'm just going to follow the outside, but I wanted to point out that any rock can become any other type of rock because it can enter at any point in this rock cycle. Okay, I know that sounds confusing. It just means it's not perfectly like it's going to go in the same cycle. Like an igneous rock isn't going to turn into sedimentary and then metamorphic and back into igneous. In fact, it could be an igneous rock forever. So like we find rocks on Earth that are like 3.9 billion years old. It's been an igneous rock forever, like for the history of the Earth. So I'm just pointing that out. Okay, so if something is weathered, so it's broken down into smaller pieces, then it's going to be what we call sediment. So that can be things like dirt or sand or silt. And then it goes, the process to make sedimentary rock is actually called lithification. Litho has to do with stone or rock. So it's going to get like kind of squeezed, and like layers will form and form and form. Some kind of mineral will cement it together and we'll have sedimentary rock. Then we have metamorphism. So the rock is exposed to some sort of heat and pressure and squeezing, and it'll form metamorphic rock. And then if something melts, then we can get it back into igneous rock. Okay, so that's the rock cycle. But again, you can have sedimentary rock that breaks down and becomes sediment and goes back to sedimentary rock. Or it gets pushed way down deep in the crust and skips the metamorphic thing and melts and becomes igneous rock. So I just want to point out that it's not going to go in this nice little circle. It doesn't have to even move through the cycle. It can kind of sit there for a long time. I mean, like the rock on my desk. It's an igneous rock. It's on my desk. It's not going through the rock cycle right now. Probably the closest thing that will happen, and the next thing that will happen, I would guess, to it would be that it will weather away. It spins. So let's just look really quickly at parts of rocks. I know you're like, rocks have parts? Yeah, they have many different parts. So rocks can be sorted into groups by looking at their parts or what's going on inside them, if you ever looked at them. You can look at crystals and grains. So like not just, hold on, where's my picture? My like crystal picture up there. Not just those, but like, if you've ever seen something like a geode, rocks do have crystals in them, or they have grains, like little spots inside them. So here are some crystals that form. These are generally going to form in igneous rocks, but igneous rocks that form and cool very slowly. Well, what are they? The crystals are different atoms that form into a crystalline pattern. They can be big or small and fat or thin. So they're minerals that are found in the rock, like calcium of some kind, or what have you, or that just form this kind of pattern. So thinking back to chemistry about how atoms join together, they're going to form into a pattern. If you've ever seen ice crystals form, like in a video, maybe I'll link one if I have time, or I'll show you at another time when you're like, can you show me this? Or you can look it up. Look up a video of ice crystals forming on a car windshield, and you'll see them grow into like this crystal type pattern. Or ice forming on a bubble. Like, do you ever see those videos where someone blows a bubble and it's so cold outside that ice forms around the outside of the bubble? It's like this crystal of ice is growing. Well, it doesn't just have to be ice. It can be other minerals that are forming this crystal pattern. This happens when these rocks cool very, 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 very slowly. But what about grains? So if you can kind of see, they'll have like little grains. Grains are smaller pieces of rock or sediment, and grain size is something that we use to like help decide what type of rock it is or how it was formed. So I know, right? You're probably like, I didn't know rocks were like that complicated. But I just wanted to add that in there. So you're going to be doing a little bit of work with the rock cycle. You'll make something and do an interactive just to kind of test what you know about the rock cycle. So I hope that helped you understand the rock cycle a little bit and get excited. Preview, here's something that you're going to make. Wow, it's not a rock. All right, I will see you later. Bye.